Okay, finally for today, CP/M. Previously, I've shown CP/M running on this board using the original MAP80 VFC BIOS and a floppy disk controller plugged in, a floppy disk rather plugged into the controller here. I've now done a port using that same BIOS to support SD card images, and I debugged that using David Olday's emulator and assembled the code from within the emulator using M80 and L80 and the original source code. And now I can boot into CP/M without having any other disks attached, and all of the storage is taken from the SD card. So firstly, let me change the character set, and as I showed earlier, the character set is maintained across reset, and now I can use the R option and boot into CP/M. And the other thing that we can see here is that both of the monitors are active, and when I booted into CP/M, the other output, the NASCOM output, flipped onto this other screen, and you can actually see how this area of the screen is actually used as workspace for the boot menu execution. So this is actually the instructions for the SPB for loading these images and starting up CP/M. The fact that both the monitors now work simultaneously, display simultaneously, means that you could use one of them as a kind of debug console for an application that was running on the other. Both of them can be paged in and out of the memory, so they don't interfere with the running application. So here we have now two virtual drives A and B, which are mapped to the SD card, two drives which would be implemented on the floppy disk controller if I had any disks attached, and now I've got my drive A. You can see the drive light come on here, and I've got my drive B, and I've also got a virtual disk on P, which is using the MAP80 256K RAM boards, which are implemented as part of the FPGA into the RAM here. So for example, I can do this. Stat B shows me 640K. I can do stat P, and it shows me that I've got a 446K RAM disk. Of course, the RAM disk, when you're using a magnetic floppy, the RAM disk was significantly faster than rotating disk, but when the alternative is the SD card storage, the RAM disk is only quite a bit faster. It's not massively faster. So there are, on the SD card, there are 16 virtual disk images, and just as for PolyDOS, there's a utility for mapping between the A and B drives in CP/M and the images on the SD card. So at the moment, these drives are mapped to disks 0 and 1, and if I can change this, I think all of the other disk images are empty, but if I set, I can set drive B to drive 9, for example. And now, firstly, set drive shows me the mapping to drive 9, and secondly, if I look at B, I'll see it's just got a single text file on, which tells me that it's drive 9. So this pretty much means you can build the simplest system now. You don't need any of this logic at all. The minimum system for running this is the FPGA card, the memory chip, maybe a buffer for the serial port, and the SD card and the connectors for the video. And all of this stuff, the rest of this stuff is purely optional.